Hey, Algebra students, let's look at Unit 4, Lesson 3, Interpreting and Using Function Notation. So we have 3 goals here. They're a little bit long, so if you need to, pause the video so you can get them written down. I can describe the connections between a statement in function notation and the graph of the function. So we want to be able to make a connection. We want to be able to go, okay, this is function notation, and this is what it's representing on the graph so that we see how they're connected. I can use function notation to efficiently represent a relationship between two quantities in a situation. So function notation is just a way to represent essentially the x value to the y value and show how that connection happens. I can use statements in function notation to sketch a graph of a function. So if we have a few things of information written in function notation, that should allow us to map out kind of a general idea of what that function would look like as a graph. Our vocabulary is staying the same. We still have dependent variable, so basically the y value here, the thing that is caused by the independent variable. A function, a relationship between an input and an output value where there is only one output for every input. Function notation, which is just a method for writing a function very efficiently to show that relationship. And independent variable, which is the variable, the input that we are putting into a function or a relationship to get our output, typically our x value. All right, for this warm-up, you're going to use this graph to answer these 4 questions as best you can. The first 3 should be very simple to try and figure out, and the last one is going to take a little bit of thinking. So, the graph represents function f. So this is function f, which is telling us the height of a drone in meters t seconds after leaving the ground. So here we have the height. Notice no numbers. It's not really what's important here. And then we have seconds, t. So we need the times to figure out the function notation. So we're going to compare f of 0. So if we go to 0, looks like it's down there, to f of 4. We go to 4 and go to where it is. I want to know which function value would be greater. Would f of 0 or f of 4 be greater? And then you do the same thing for the other 3 situations. So the first 3 should be simple. Look on the graph, estimate as best you can, see which one should be bigger. The 4th one, you're going to have to think a little bit, and maybe there's different times where one is greater than the other. Remember, greater means bigger, so it could be that at certain times they are the same, or they switch which one is bigger or smaller. All right, bring that to class tomorrow, and that'll start our discussion. Thanks.